Hey everyone, we are the Terumo BCT project team, and this is a presentation of what we worked on for our capstone project throughout the school year. So our team members include myself, Erik Pohle.
My name is Ruijiang.
My name is Sean Flood.
And my name is Simon Koeten.
And we're all part of the Terumo team. So a little bit about Terumo. So Terumo is a blood and cell technology center. It's a global leader in blood component therapeutic apheresis and cellular technologies. They believe in unlocking potential of blood and cells to do even more for patients than it does today. In addition, they are the largest medical device employer in Colorado with over 2,500 associates at our global headquarters in Lakewood, Colorado, with nearly 7,000 associates throughout the world. They serve customers and patients in more than 130 countries with 5 regional headquarters and 6 manufacturing facilities worldwide. As an innovation-driven company, they hold more than 750 granted patents with more than 150 pending patent applications.
This is the Revia system from Terumo BCT, the core of our project. It is a medical device that can separate 4 units of blood into the individual components: plasma, platelets, red blood cells, and white blood cells in a single 20-minute procedure. Each Revia's procedure generates run data that records hundreds of values multiple times a second. With these run data, they are often the point of first detection for device failures. However, Terumo BCT does not currently have an efficient way to monitor these thousands of run data files received each day.
So since the current device anomaly detection mechanism is passive, so the system will not find that a certain machine has a problem until it receives a notification from the customer. So the objective of our project is to develop a machine learning evaluation framework that can be leveraged to improve the quality response time for the Revia's automated blood processing system.
And as for the benefits of this project, basically it, if deployed, would replace like a dashboard that's got a number of hand-created rules that they use to do some monitoring, but it was only with problems they knew to exist prior, and the vast majority of customer issues were they would just wait on a notification from the customer. So by automating outlier detection for the purposes of catching these problems with machines and doing maintenance on them, it would greatly improve operational efficiency and reduce operating costs. And for the customer, it would mean that instead of them calling Revios to say their machine's broken, Revios would call them and say, hey, you should do some work on it before you have some potential problems in the future. So it would definitely help our customers just in having a easier life, easier workflow and working with these machines. And of course, for us, we gained exposure to different methods of applying predictive analytics, which is, of course, a vastly growing industry these days.
So our overall intention for this project was to perform data analysis and develop machine learning models to gain insights and potentially predict anomalous device behavior. This was just in hopes that Terumo would then be able to perform maintenance to the device before it even breaks or has any complex problems. So we decided to approach this problem in a few steps. First, we knew we had to get a hold of the data from their SQL database, which was hidden behind a private network. So once we had access to the data through a VPN that Terumo provided, we had to then import that data into our notebooks so that we could perform some data cleaning. Doing so was difficult simply due to the size of the data that Terumo had provided. After the data had been cleaned, we started getting the data ready for use by our models. We first had to choose what features we wanted to look into and which ones should be written off until later. Afterwards, we started to reduce the size of each feature column, simply by casting the data to smaller data types when possible. Once all the pre-processing for the data was complete, we moved on to creating different models, ranging from k-means clustering to logistic regression models. Then after the models had finished training and we computed their accuracy scores, we started to visualize the conclusion each model had reached through the use of graphs and confusion matrices. Once all the models were finished and our analytics were completed, we began to write formal documentation with the intent that the Terumo team would be able to easily understand the processes and follow up with where we left off.
A goal for us was to provide Terumo BCT with documentation that would allow for them to pick up where we eventually leave off. As such, we laid out documentation as a formal research summary broken into multiple sections. The first included any and all recommendations we as a team could come up with. That includes future data wrangling techniques, how we handled the aspect of big data, and how that process can be improved, the various improvements that we made to each model, and kind of what we could do if more computing power is available, and even possible aspects of cloud computing that could enable further large-scale analytics with other data sets we didn't have time to examine and clean. After laying out all the recommendations we had for the Terumo BCT team, we dove into the basic analytics and data wrangling that had been performed. An initial hurdle we had was accessing the data, requiring us to use a VPN to connect to their SQL database. We documented those struggles along with our solutions to some of them, with the hopes that Terumo can learn from those roadblocks. In some cases, we didn't have the required resources to handle the large amount of data, and as such, we simply noted where further data exploration could be done. A large portion of this project was spent on data wrangling, and due to its unwieldy size, we opted to perform operations that would reduce the size of the overall data set. We documented this process as well for Terumo, since we found it extremely helpful for allowing lower end computers to perform some of the low level analysis. After data wrangling, we started to document the process of creating different models for analytics. Firstly, we went over each different model type, the results we encountered, the model success and failures, and possible improvements for each model. Due to the sheer size of the data, our model struggled to run when more than 2 features were trained on, and as such, we were forced to intentionally limit the scope of our data. We documented further areas of improvements for models, specifically which features we would want to see run against on the future. Finally, after documenting all the different models and techniques we used, along with some of the results, we finalized all our research and made specific claims about which models hold the best future for determining anomalous figures. Specifically, we found our cluster models to be the best for predicting when anomalous numbers within a dataset may occur. Since we didn't get to analyze all the datasets that were provided to us, we also summarized what parts of the data might be most interesting for future development.
And as for the success of this project, we definitely were able to soldier through and gain some success, primarily in learning a lot about actually working on a real world problem versus the much smaller problems we'd worked on in our machine learning and other similar classes. And likely the biggest issue was we neglected to set up a big data processing framework such as Spark, and that is definitely a crucial step that we've recommended to Terumo to set up for their future development processes. As again, in our more academic settings, we'd use smaller data sets that would run on our computers or would at least run slowly, whereas this large data set, in the absence of special software to either run it on like a Google cluster, or at least run it in some sort of parallelizable manner, like with the Dask wrapper for Pandas, a number of our devices either just weren't able to load the data at all, or as my partner mentioned, we were only able to load in a few features before overwhelming the resources and just having the, computer basically shut down. So, that was one of the big kind of, resource issues that we had to deal with. And, we also had to deal with, a lot of intricacies put into place as a result of working during the pandemic and not being able to meet in person, which may have helped us kind of soldier through some of these machine-specific issues that we'd had, as some newer computers were able to process the data and some of the older ones miserably failed at the task. But yeah, this was again, a learning technique and just kind of everything that needs to be done, and organizing a team, working remotely, and just dealing with big data. So ultimately we learned a lot and got that documented for Terumo, along with documentation of our results that were scaled back from what we had initially envisioned them to be.
So throughout this 8-month project, the first lesson we learned is being consistency. It's being consistent. Consistency means to show up every meeting, to do the best every time, and meet what other teammates expect of you. Aside from being teammates, we all have other roles in life, and sometimes it may conflict with ongoing tasks. And this is when preemptive and active communication become crucial. We want to be crucial. We want to be active for our teammates so that they know we are consistently responsible. Technology-wise, a lot was learned during our time with the data provided. Due to its size, loading all the data from the SQL database to a pandas framework data frame took a time and massive amount of computing. Some of our machine, despite being relatively new, were unable to handle the data due to its sheer scope. As such, we had to learn and perform new technologies that were unbeknownst to us. Some of these technologies include selective sampling of data manipulation and reduction, and other big data technologies. We also looked into and researched cloud computing solutions as a potential solution for our hindrances by our local hardware. However, quickly realized that wouldn't be a feasible solution due to the confidentiality issues regarding the data. All in all, we were able to find solutions and work around for most of the issues we encountered with big data, which in turn will help us prepare for future in the real world. And finally, we also learned how to write and summarize large amount of analytic and data into a readable and a comprehensible document for the Terumo team. Despite not having much experience regarding documentation of a project, we were able to read through example document and data analysis and formulate a plan for our own documentation. With a heavy focus on maintaining readability, we're still discussing the complexity of the data.
So yeah, that's about it.
Yeah.
That is the presentation for the Terumo BCT capstone team. Thank you for your attention.
Thank you.
Thank you. Thank you.